Today we'll be looking at dynamic programming, which will be a soft intro to 01 knapsack, which will be the topic we would look at next time. So dynamic programming is solving problems and using tabular computation. So we are going to be filling up the table in a dynamic fashion. Now, dynamic programming is used to solve the knapsack problem more efficiently. The knapsack problem, which we'll be talking about in the next video, actually, is a classic optimization problem that can be efficiently solved using dynamic programming. And that's why we are talking about dynamic programming today. This dynamic programming is particularly well suited for knapsack problem because it involves breaking down the problem into smaller overlapping sub-problems which can be solved once and then reused. So let's just take a quick look at what dynamic programming looks like, and by the next video we'll jump fully into the knapsack problems. So for dynamic programming, like I said, we want to solve a problem by filling up the table and then using the values in the table, which will make solving the problem easier. Let's take a very popular example, the Fibonacci sequence. Let's look at the Fibonacci sequence. If you know the Fibonacci sequence, we know that the first item in the table is 0. Let's call it 0. Second item in the table is 1. And then from the third item, will be a sum of the last two items. The fourth item, sum of the last two items. That is, the third item will be a sum of F0 and F1. The fourth item will be a sum of F2 plus F1. That way, that's how it continues until you decide to stop. So let's write a short algorithm for this. We've written the first line already. We just set the values for the first and second items, or first and second, let's say cells if it's a table. If you're putting the items in a table already, first and second items in the table. So the next thing you do is, for n greater than or equals to, fn would be fn minus 1 plus fn minus 2. And this is a recursive substructure. And this because this is the formula that gets you your Fibonacci number at each point or at each n. So what this algorithm says is, if n, for this point we could write it, say if n is equals 0, we return 0, right? If n is equals 1, we return 1. Then we do this. Else, let's write this more elegantly, else return so this is what it looks like. So let's take an example. Let's say we want to find Fibonacci 4. So this would be Fibonacci 3 plus Fibonacci 2. And to find Fibonacci 3, that would be Fibonacci 2, Fibonacci 1. This would be 1, this would be 0, this would be 1, and this would be 0. So this is what the recursive structure looks like. So to find this, if we have this f and 3 already in our table, we don't need to recompute the fourth Fibonacci number from scratch. That's just what this expression is trying to say. So if you're asked to compute this, for example, we check our table. Let's say this is the table, right? Let's start from the first 0, then 1. Then we want to compute the next one. That's 1 again, because 0 plus 1 is 1. We want to compute the next one. That's 2, because I'm adding this, right? This is 0, 1, 2, 3. Now to compute this, you just have to look. What's at F3? What's at F2? You have this, so that gives 3, right? To compute F5, you'd have to check what's at F4, what's at F3. That's 2 plus 3, that's 5. So that's how the dynamic programming works. And the complexity of this, when we use dynamic programming, is O of n. That's because we are storing items in a table. Supposing we were not storing any of these items in a table, if we are to compute for this f of 5, if we were to compute f of f5, if we did not store any of these items in the table, we will have to start computing from f0 all over again, and this would make computing this Fibonacci sequence expensive. But storing the prior information in a table makes it cheap to compute the Fibonacci number or sequence for any position on the Fibonacci, because we have calculated the numbers before them. So we just have to pick the last two, add them, and we have the next one. I hope this brief introduction of what dynamic programming is made sense to you. If we are to recap everything in this video, dynamic programming is simply storing information in a table. That's a tabular computation, in such a way that when you need the next number, you just look at your table, grab the last two, perform some operation. In this case, it's addition for Fibonacci. You add the last two, you have the next one. You do not have to compute again from scratch. So that's simply what the dynamic programming is, and we'll be using this, like I said, in the next video, where we'll start talking about the 0-1 knapsack problem. Thank you for watching this video. We'll stop here. If you did like it, please subscribe and like, and I'll see you on the next one.